This is the intro video for simplifying algebraic expressions. In this video, we're going to talk about a little bit of terminology and then several examples of how we can simplify algebraic expressions. Okay, so the parts of an algebraic expression. This one right here is 3x squared minus 8x plus 4. This algebraic expression has what we call three terms. So I will underline these terms here for you. There is one term right there. There's another term right there. Third term is right there. So the first term would be 3x squared. The second term would be negative 8x. And the third term would be a 4. You can see that you go from one term to the next whenever you see an addition or a subtraction symbol. Right here, this indicates we're coming to another term. That indicates we're coming to another term. And so we've got a total of three terms. So the word term is quite important here. It's not just thing, right? So there's more than one thing here, but there's more than three things really, but there are exactly three terms. So within the terms, a couple of other expressions or terminology we want to know here. The 3 is known as a coefficient. This is typically the numerical part of the term here, the numerical base that's being multiplied times the variable. The 8 is also a coefficient. And the 4, because the 4 does not have a variable with it, we would call that a constant. So there's a little bit more to this than what we've talked about here, but I think this is good enough for now. So what we're going to do is we're going to practice simplifying these algebraic expressions a little bit here in the video. We'll do a lot of this when you come to class. Okay, so the way that you simplify algebraic expressions is to add like terms. So let's talk a little bit about what like terms are. Like terms are terms that have the same variable, and that includes the exponent on the variable. Okay, so when we take a look at number 1, it says simplify, we look here and kind of like our previous example, we've got three terms. I'll erase this here in a second, but there's term 1, term 2, term 3. So we need to decide if any of these terms are like, and if they are, what do we do with them? Okay, so I look right here, 5x is my first term, and positive 6x is my second term. Those are like terms because they have the exact same variable, and they have the exact same exponent on the variable. Of course, the coefficients are different, a 5 and a 6, but for like term considerations, we don't care about that. We just care about what's going on with the variable. So what do we do with this? When you add like terms, what you do is you leave the variable alone. So the variable is just going to be an x, and you add the coefficients. So 5 plus 6 is 11. Very simply, basically what you have here is you have 5x's and you have 6x's, and if you add them together, you get 11x's. So 5x plus 6x ends up being 11x. And the 7 did not have any like terms to be combined with, and so that one just gets left out there. 11x plus 7. You cannot say that 11x plus 7 is 18x because 11x and 7 are not like terms. Okay, let's take a look here at our last couple of examples, number 2, and then we'll talk about the distributive property. Okay, so with number 2, a little more complicated here. We're going to go through and try to find like terms. So my first term is 4x squared. I'm going to put a box around that. I look to my next term is negative 9x. Negative 9x is not like 4x squared because they do not have the same variable. One variable is x, the other one is x squared. The exponents are different. So that just means that those two terms are not like terms. But when we get to this term, positive 3x squared, it is like 4x squared because they both have the same variable. They both have x squared as the variable. And then you look at negative 5, you can see that that doesn't even have a variable with it, so it's a constant. And 8x also not like those two terms. So those are not grouped with the x squared term. So 4x squared plus 3x squared, we add the coefficients. We leave the variable the same as is. So we get 7x squared for those two right there. And I think there are more like terms here. So for example, negative 9x is not like the negative 5 because the negative 5 doesn't have a variable with it, but negative 9x is like the positive 8x. They both have a variable of x. And so when I add these up, once again, I add the coefficients, leave the variable alone. Negative 9 plus 8 is negative 1, negative 1x. And then lastly, I've got my negative 5. Well, there is no term like negative 5, so that just gets dropped down into our answer line. And our final answer would just be that, 7x squared minus 1x, or you could just write it as minus x if you want. It's the same thing, minus 5. Okay, and then finally the distributive property. I found that a lot of folks have seen this in middle school. If you haven't, that's okay. The distributive property, to distribute means that what you essentially have is a multiplication times a quantity, times usually an addition or a subtraction. And so we're going to do a couple of examples here, and in class, we're going to really dig a little bit deeper into what the distributive property really is. But for now, what we're going to notice here is that we've got 7, numerical in number here. It doesn't have to be a number, but you got something. And then something really important to note here, of course, there's no symbol in between the 7 and the parentheses. So whenever you butt up against the parentheses, it's assumed to be multiplication. So we're going to write this, or think of this as 7 times x plus 3. If it was 7 plus x plus 3, that's not the distributive property. It's 7 times, and so this is the distributive property. Everybody has seen the little rainbow thing that's ever seen this. I think this is a pretty effective graphic to remember what to do here. So it's 7 times x, which is just 7x, plus 7 times 3, which is 21. So the 7 gets multiplied by both terms on the inside. And number 2 is very similar. I've got negative 3, and again, there's no symbol in between the negative 3 and the parentheses, and so I'm just going to put a little dot in there indicating that it's multiplication, making this the distributive property. So negative 3 gets multiplied times x, which just gives us negative 3x. Negative 3 gets multiplied times negative 9. Negative 3 times negative 9 would be a positive, and 3 times 9 is 27. That would be your final simplification there. Okay, so we'll be practicing this a lot over the next several days. Hope this went well for you. See you in class.